Today we're going to talk about bearings. Welcome. Thanks for joining me. There's a lot of different styles of bearings out there, and bearings are designed in such a way that they help us reduce friction between different components. Without bearings, things would be a lot harder to move and parts would wear. So we're going to break down the different styles. Now, on this table, you see a pile of different bearings on there. So we're going to eliminate some of them and start talking about them one by one. Now, I think a good place to start would be with your common ball bearing. Now, we've probably all seen ball bearings somewhere before. Bearings like this are called anti-friction bearings. Whenever we have rolling elements on the inside of a ball bearing, or in this case a tapered roller bearing, or a needle bearing, or a Torrington bearing, we have what they call anti-friction bearings. Now, anti-friction bearings all have the same in common. They have rolling elements. Now, this specific type of ball bearing that I'm looking at has a few different parts, and most bearings that are anti-friction bearings have these parts. Generally, there's going to be an inner race, and they call that a race because that's the component that the rolling elements, in this case the balls, race around. So we have an inner race and we have a outer race where the balls race around as well. Now, this style of ball bearing that we're looking at is actually called a Conrad ball bearing. There's a space between the actual balls in there, and we hold the balls in their respective places by a cage that goes around them. Now, Conrad ball bearings have a unique feature to handle loads in two directions. They can handle what we call thrust loads or axial loads in line with the axis of rotation. So that would be an axial load. And if we turn it this way, they also can handle radial loads, loads that are coming perpendicular to the axis of rotation on it. Conrad ball bearings are designed to handle those loads because of the way the balls sit in their grooves. They're kind of locked into a groove, and because there's a concave shape that they're sitting into, when we try to push the balls, they're locked into that groove, so it handles loads this way as well as that way. It makes ball bearings ideal for many different situations. Now, on some cases, if you want a heavier, what we call radial load capacity, what we'll end up with is not a Conrad ball bearing, but they'll put a full ball bearing. We'll actually put more balls in it. Now, it's pretty hard to build a bearing that is completely full of the balls unless they cut a little slot in the outer race generally, and they load those balls in to do that. So if we do that, they do not handle axial loads very well because there's a risk of pushing those balls out of that groove. There's usually a little guide on the inside to prevent the balls from coming out, but it can't handle a lot of side loading. So those bearings are specifically designed for heavy radial loads and not axial loads. Okay, I want to show you another type of bearing here. You're looking at also a ball bearing, but this bearing has on it seals. There's seals on each side. Now, this is called a sealed ball bearing. And sealed ball bearings are meant to run in places where they're not exposed to oil regularly, and they basically have to stand alone with their own lubrication. And they can be used in all kind of different environments, and they last quite a long time. Now, bearings have to be checked if they've been run a while, especially if they're sealed bearings, to see if they still are functioning properly. Now, these bearings can last for years, but there comes a point when the grease can escape from them and then they start to fail. So one thing you can do with a bearing is to put it in your fingers, or if it's on a component, you can spin the component and listen to it. If the bearing's got a rough sound to it, that's indicating that the bearing internally is starting to fail. So this bearing, even looking at the body of it, has been through a lot of time and wear and tear and corrosion. So this bearing is an example of one that should be replaced. Okay, now we have an example of a tapered roller bearing here, and you see the outer race, the inner race, the cage, and the individual rollers on there. You got to watch on tapered roller bearings. Not only are you looking at the condition of the rollers and the races themselves, but you also got to look at the condition of the cage to make sure the cage isn't distorted or bent. And you want to make sure that none of the rollers are going to be able to pop out of that. So condition of the cage is just as important as any other part of the bearing. A lot of times when you look at bearings, you're going to see numbers on them. We use those numbers to reorder new ones. So, there's many different styles and manufacturers that make these bearings. So if we can go by the numbers, we can pick up a new one. And one line of bearing can cross over to another line if they can do what they call crossover referencing with them. So that's a tapered roller bearing. One of the, generally one bearing out of two, once more, you'd have an opposing bearing that would go the opposite way to handle thrust loads or axial loads in two directions, as well as a radial loading on it. Tapered roller bearings. Now, what I don't have here is the race that go along, and I've brought a big bearing. Lots of damage on this one. You can see the effects of loading on this one, and likely materials that have gone into the area where this bearing was and done some damage. Quite frequently you get a bearing will end up establishing that kind of problem when you end up having overloading and material contamination there. So this bearing is what we call badly spalled. Bearings end up with all kind of conditions of wear on them, including what we call scoring, where there's lines on them, pitting. This one's also heavily discolored. It's quite brown in its color. If they get bluish, that means they've been overheated. So anytime you have a bearing, you want to look on the rolling elements. In this case, it's got rollers. If it's got balls, you want to look at that, or needles. Look for damage, signs of that the surface is no longer smooth anymore. Now, if you get a blue bearing, that usually means it's been overheated. Quite often when they run low on lubricant, you'll overheat the bearing, or if they're overloaded, they'll overheat on you. So this bearing is definitely shot, but a tapered roller bearing is an interesting bearing. They usually work in pairs. You usually have one bearing facing with its taper one direction, and the other one faces it in the opposite direction, so the tapers face each other, and they're allowed to manage axial loads when they're paired in two directions that way. If you have a single bearing that's a tapered roller bearing, they really don't handle axial loads two ways. They only handle it one way, so that's why they're always combined in pairs, opposing tapered roller bearings. Now these two will have an inner race, they have a cage, and they have an outer race, which in this case is missing. Okay, so that's a tapered roller bearing. We also have needle bearings. Now needle bearings are meant to be in places where you do not have a lot of room between, for instance, this case, the shaft and housing that is going into. So you want a nice slim bearing. So needle bearings fill the gap for that need. And you see these in all kind of different places. This happens to be out of an automatic transmission. You'll see them in places like U-joints. You might see them inside of a manual transmission in case of the cluster shaft. And this one, they have needle bearings on the inside of the cluster shaft between the actual counter shaft that goes through it, where it rotates, and the cluster shaft itself, packed with grease. Those needle bearings are usually installed in there, and once we're in the housing, the oil then lubricates them. But that's a perfect place for a needle bearing. Now you also see bearings that are kind of like needle bearings, but they're called free roller bearings, where they'll go in a housing where the housing itself has got a raceway, or inside of a shaft where there's a raceway cut for it, and another shaft will appear inside of that one, so it isolates between components and shafts. And this way you don't need the complexity of a full bearing with its in and out races. You actually use part of the component to form the race. Now, any bearing once more that has rollers is called an anti-friction bearing, but we also have what they call friction bearings. Now, this is an example of a thrust washer. You can see that it's got a bronze base on it, and bronze or brass is used as a material, and you'll see that there's actually little pockets cut in the face of that thrust washer. Now, thrust washer is actually a type of bearing as well. It is a bearing that has no rolling elements, so we don't call this one a anti-friction bearing, we call it a friction bearing. Friction bearings simply rely on sliding friction or rubbing friction, and they rely on the grease that's on it or the oil, and the parts when they come together actually hydroplane on that surface of oil or lubricant. Now, thrust washers handle strictly axial loads. They're not meant to handle radial loads, so just pushing forces against them or side loads. And there's another style of there's another style of friction bearing called a bushing. You can see a sleeve inside. Bushings are really just sleeves, and they're another style of friction bearing. They rely on lubricant and hydroplaning forces between the components. So no rolling elements on this either. So bushings are simply sleeves. Again, they can be made of bronze or brass, or they may sometimes use a material called babbitt, which is usually backed by brass. Babbitt is a type of lead material with some alloys in it. It's fairly soft, but when it's lubricated, it is very gentle on the components that rub against it. Here's a little bigger picture of a bushing. You can see the inside, that sleeve there. Now, bushings can also be made of nylon or Teflon, because that works. One thing about Teflon and nylon, they're almost self-lubricating, so they don't really use grease, or if they do, they'll often use a silicone-based lubricant inside of it. That's the bushings. Now, another style of thrust washer here, you can see the coating on that is actually got a grayish material. That's what we call babbitt, and that's that lead alloy material that sits coated on top. You can see indications of there being a brass or a bronze material behind it, probably brass, with a steel backing on it, so it holds some form in there, and the steel gives it some strength. Okay, that little bearing there is a type of thrust washer, but it's a thrust washer that's actually an anti-friction bearing. It's got the ability to handle axial loads really well. This is used in a torque converter. It's part of an automatic transmission, and it uses needles spread out flat rather than around a raceway. So different style of bearing, and it's there just to reduce the friction between components. It does the same job as a thrust washer would do over here, but it does it as an anti-friction bearing versus a friction style bearing.